This is lesson 2. It's about the volume of prisms and cylinders. I'm going to work through some problems with you. We'll write down some notes, and then you're going to have some practice problems to do at the end. While you're watching the video, you want to be taking the notes. If you need to pause the video, feel free to pause it, rewind, do what you need to do there. Also, if you need to ask your teacher a question, you can do that. I would make sure that you have your calculator next to you and that you do the problems with me. I've done them ahead of time, so that's why maybe it'll seem like I'm going really fast, but I've done the problems ahead of time, so I have the answers. But if you pause the video and do the calculations to make sure they match mine, then you can make sure you're understanding the steps properly. You watched a video about prisms, and so in this prism right here, it would be called a triangular prism. The reason I know that is that it has two bases that are exactly the same. So this triangle here is the same as this triangle here, and so that's the base. So this is a triangular prism. It's not sitting on its base, but if I were to flip it and set it on the triangle, then I could easily see that the triangle was the base. So in the last video, we kind of highlighted the base. You could highlight the back triangle or the front one, it doesn't really matter. Or you can just visualize it, but that part right there is my base. The way we're gonna do problems like this is in order to find the volume, meaning how much stuff would fit inside of this prism, I'm gonna do volume equals area of the base. So I have to find the area of the base. Then I have to do times, so I'm going to do parentheses for my times, and I have to do the height of the prism. So that is kind of the formula that I'm following: area of base times height of the prism. The way that I typically do these then is I kind of do two steps. First, I have to think about the base. We said in this picture the base is a triangle. I like to actually draw my triangle so that I can see it. I see a right angle in it, and then I see some measurements that go with my triangle. I see 12 feet on this side, I see 9 feet on this side, and then even though I don't see it in this one, I see a 15 feet that goes with the hypotenuse. So I know that I have 15 feet here as well. What I need to do, according to my formula, I need to find the area of the base. The base is a triangle, and I know that the triangle formula would be base times height divided by 2, because that's the formula that goes with a triangle. When I look at my triangle, it looks like the base is 9. The height of my triangle is 12. And then, because of the formula, it says I have to divide by 2. When I type that in my calculator, I found out that the area is 54. But I'm not solving for area, I am solving for volume. So I have to do another step. Now I have to do the volume part of my equation. In order to do the volume part, I have to do the area of the base. I just found that, 54. Times the height of the prism. This is where you have to be careful. The height of the triangle was 12, but that's not how tall this prism is. Remember, if we were to take this prism and stand it on the base, so if this prism were standing on the triangle part, it would have a height of 16 feet. Another way to think about that, if you're having trouble visualizing, is how far is one base from the other base. So to get from one triangle to the other triangle, because those are the bases, I would have to travel 16 feet. So the height of the prism is basically how far is one base from the other base. Then I'm doing volume now, so I can use capital V for volume. When I multiply those two numbers, I got the area of the base from here. The height was how far apart the two bases are. And when I multiplied, I got 864. And then anytime we're doing volume, we measure it in cubic units. So I would have to say my units feet, but they have to be cubed. We are going to be giving credit or taking off credit for units, so make sure anytime we do volume that we have units to the third power for volume. This next shape is called a cylinder. Another thing you could say is you could say a circular prism, because that kind of reminds you that the base is a circle. So I'm going to highlight my base. You don't have to do this step, but if it helps you out, you should go for it. And then I know that my first part is I have to find the area of the base. My base is a circle, and on my circle I see a 6 centimeters for that circle. The area formula for a circle is pi times the radius squared. Since I already have the radius, I can just plug it in. Pi times 6 squared, and then you can type it into your calculator. I already typed it in, and I got 113.097. But that's the area of the base. I was asked to find the volume, so I have to do another step. In order to find the volume, I could do capital V. I have to do the area of the base. That's this number that I just found, 113.097, times the height of the prism. This one, it's easy to see the height because it's standing on its base. So from the bottom to the top of this shape is 15. But the other definition also works, right? How far is this circle from this circle? I would have to travel 15 centimeters to get there, and so that's the height of the prism. When I multiplied these on my calculator, I got 1,696.455. And now I did all the parts of my formula. I found the area of the base, I multiplied by the height of the prism, and now I have the volume, so my units would be centimeters to the third power. So we'll fill in this last box, and then you'll have some problems to practice on your own. To find the volume of a prism or a cylinder, so anytime you see a prism or a cylinder, the volume, capital V, is going to be area of the base. So I have to do a formula for that. I can't just look and see a number. I have to do a formula. And then I have to multiply by the height of the prism. And the height of the prism, if it's standing on its base, is basically just how tall it is. But if it's not standing on its base, you can also think about it as how far away is one base to the other base. You have two problems that you can practice. You are finding the volume, so anything we did here can help you out. And then when you're done, when you have all your work and all your notes done, you can have your teacher and they'll write their signature right here so that you can move on to the next video.